Okay, so we're going to talk about the last criteria, which is that a molecule must satisfy Hooke's rule, which requires a particular number of pi electrons. So now let's look at what Hooke's rule says. Hooke's rule says that an aromatic compound must contain 4n plus 2 pi 4n plus 2 pi electrons, where n can be 0, 1, 2, and so forth. Now, if a molecule is cyclic, is planar, that means it satisfies criteria 1 of being cyclic, criteria 2 of being planar, criteria 3 of being completely conjugated. But then, under his Hooke's, it now contains 4n pi electrons. Those molecules are especially unstable and are said to be anti-aromatic. So if a molecule satisfies 4n plus 2 pi electrons and other criteria, it is said to be aromatic. But if it now satisfies 4n pi electrons plus other of the 3 other criteria, it is said to be anti-aromatic. So we have aromatic and anti-aromatic. Aromatic is it satisfies all 3 criteria plus 4n plus 2 pi electron criteria. While anti-aromatic is satisfying the 3 criteria plus 4n pi electron criteria. So now let's look at what this 4n plus 2 pi electrons and 4n criteria means. So if n is 0, we're going to, if n is 0, we are calculating with 4 times 0 plus 2, which is 0 plus 2. That's 2. That is why we now have 2 pi electron here. If n is 1, it's now be 4 times 1 plus 2. That's 4 plus 2. That's 6. That's how we had 6 here. Okay, so if n is 1, you will now calculate 4 times 1 plus 2, 6. And if n is 2, like that, because we said our n can be from 0, 1, 2, and so forth. Now, after calculating, we get n is 3, you have 14, n is 4, 18. Then if n is 0, we have 0 as 4n. Then if n is 1, we have 4. If n is 2, we have 8. If n is 3, we have 12. If n is 4, we have 16. So now, we have an example here. This is benzene. I want to check if benzene satisfies either this 4n plus 2 pi electron rule or 4n pi electron rule. So now we see that benzene has how many pi electrons? Benzene has 3 pi bonds. That's 1, 2, 3. This is a pi bond, this is a pi bond, this is another pi bond. And now we know that 1 pi bond is 2 electrons. So 3 pi bonds is going to be 3 times 2. That is 6 pi electrons. Now, these 6 pi electrons, we're going to now come to this table and trace. We now see that there's a 6 here. So it's satisfying Hooke 4n plus 2. When you come under this place, there's nothing like 6. Under this 4n table, there's nothing like 6. What we have is 0, 4, 8. So since there's a 6 here, so benzene satisfies Hooke's 4n plus 2 pi electron rule. So that's just it. So if a molecule satisfies this rule, it does not define if it's going to be aromatic. It has to satisfy others plus this one for it to now be said to be aromatic or not. So we're going to take some examples of how to know when a molecule is aromatic, anti-aromatic, or non-aromatic. Thank you.